All right, Algebra 1 folks, thanks for joining in again today. Picking up where we left off on the last lesson, we got an opportunity to see shapes of data and some of the names that we have for them and what those shapes really mean to the data and how we can use it. Today we're going to look at how to identify a true outlier. So outlier is a term that we've been using here throughout the last week and a half or 2 weeks in our Algebra 1 class. But today we need to really figure out the mathematical formula for how to find a true outlier. A lot of what we've seen so far up through middle school and into the first week or two of ninth grade here in Algebra 1 is just kind of looking for an outlier with our eyes. Is there anything that looks like an obvious outlier? And then if so, can we identify that? So that's kind of what we have this first bullet point being. It says some outliers are very easy to notice, and which is seen on the list below. Here we have, it says the last 6 paychecks you got working at Little Caesars. Those paychecks were $188, $176, $201, $198, $32, and $210. Now, one of those numbers is very clearly an outlier to us. We say very clearly because this 32, is not even within, it looks like $140 of our next closest paycheck. And those other paychecks are really within, besides 32, they're within it looks like $30 to $40 of each other. So why was that paycheck only 32? Who knows? Maybe they only worked one shift that week, or maybe they had to put some of their paycheck back into getting a new uniform if their shirt got dirty, things like that. Many different reasons why that paycheck could be lower. So anyways, again, sometimes very obvious. Sometimes it's not as easy to see though. Sometimes we get some data sets where we're like, that looks like an outlier, but we need to know exactly how to find out if it truly is or is not an outlier. It can be done in 4 steps. I have the 4 steps below. I just want to kind of go over them with you. And then I'd like to go over them with you in an actual example where we're going to walk through and use numbers themselves. So the first thing that it says we can do, step number 1, it says find the IQR, which is the interquartile range. And again, in order to do that, you take quartile 3 and you subtract quartile 1 and you get your number there for the IQR, right? So we'll get a chance to see that worked through here. Okay. Step number 2, it says multiply the IQR by 1.5. So whatever you get here for your IQR, you need to multiply it by 1.5 and you'll get some new number. Okay. With that number now, on step 3, you're going to take your third quartile and add your IQR times 1.5 to it. So that number that you found here in step 2, you're going to add that to quartile 3. Then you're going to look at your data points and say, are there any data points above that number? If there are, then you have an outlier there. Okay. If you don't, then we don't have an outlier yet. We would move on to step 4. Step 4 says we're going to subtract quartile 1 from that number that we got in step 2, our IQR times 1.5. Then it's asking, are there any data points below that number? If so, you have an outlier there. Okay. So those are really just the 4 steps. Not really much of a mess as far as math is concerned. It's just a matter of remembering these steps and putting them to use. So let's take a look at this example below. It says we have the length in minutes of the last 10 workouts that you had. So we have 70, 10, 32, 19, 22, 29, 36, 14, 49, and 3. Those are how long your last 10 workouts were that you plotted down. Okay, it says if you had to guess, are there any outliers? If so, what are they? Well, the first number that jumps out to me is this 3. Okay, I'm thinking 3 is possibly an outlier. So I'm going to write down 3. No other numbers seem too small. The only other number that seems like it could be an outlier is 70. So I'm going to write down 3 and 70. I'm not sure if you agree or disagree. Maybe you think one of them are, maybe you think both of them are, maybe you think there's more than just those 2. Take a second to consider what you think the outliers might be, and then we're going to go ahead and work our way through this. We're going to do these 4 steps here. We're going to do them together and just make sure that we can identify truly if there is or is not an outlier. Let's go ahead and start with, can I get this right there? Okay. Boom. Okay. We're going to go ahead and step number 1. Step number 1 says, Step number 1 says find the IQR. So the IQR again is quartile 3 minus quartile 1. Well, Mr. Neal was very, very nice and he organized this data from left to right. So we have it from smallest to biggest. And then we cut that data in half at the median, right? That's our halfway point right there. So then we're looking at our lower half and our upper half. And we need to find the halfway point of the lower half. Well, I bolded that number there. That's 14. So I put it here for quartile 1. And then I found the halfway point of the upper 50% of this material, and that's 36. So I put it here representing quartile 3. And then again, we just have that subtraction, right? Find the IQR, which is quartile 3 minus quartile 1. We see that 36 minus 14 is going to be 22. So that 22 is going to be a number that we're going to continue to use. Okay, step 2 says we need to multiply. Okay, we need to multiply. I'm sorry. Yes, we need to multiply the IQR by 1.5. 1.5. So I have that right here. 22 times 1.5. 22 times 1.5 would be 1.5 22s, which is also 33. Okay, so we've done that. Now we're going to use that 33 in the next couple of steps. So the next thing we're going to do is we're going to take that 33 and we're going to add it to our upper quartile. So we have 33 and we're going to add it to 36. Okay, well, 33 plus 36 is 69. Now we're trying to figure out, are there any data points higher? Go back and look at these 10 pieces of information, or I guess rearranged here, these 10 pieces of information. Is there anything higher than 69? So we're going to go ahead and notice that 70 is, right? 70 is higher, so we can already claim that 70 is a true mathematical outlier. I'm going to star that so we don't forget. Okay, the next thing that we're going to do then is we're going to take 33, which was that IQR times 1.5, and we're going to subtract the first quartile. Nope, I said that backwards. I apologize. We're going to take our first quartile. We're going to take quartile 1, and we're going to subtract it from 33, which was that IQR times 1.5. Well, 14 minus 33 would be negative 19, and we need to find out, are there any data points lower than negative 19? Any data points lower than negative 19? It looks like no. Our lowest data point is a 3, a positive number. We don't have any data points lower than that. So we would say no, there's no outliers that are too low. It says, after mathematically checking, are there any outliers? If so, which data points are they? We would say that data point 70 is an outlier. We know that because we followed these 4 steps that prove if something is too far away from the data. We go 1.5 above and 1.5 below the IQR from quartile 3 and quartile 1, and that tells us that we have a true outlier. Okay. Feel free to hop back in and watch part of that video if you think that'll help you again. The second thing we might be asked sometimes is, can we see an outlier visually? So without one big hunk of data with a bunch of different data points, what if we're just looking at something like a box plot, right? Well, I think if I use these 4 steps again, right, I'll be able to find that if we have outliers or not, right? Okay, so let's go ahead and dive right in. It says find the IQR. So we go to quartile 3, which looks like it's at about, I don't know, we'll call it 34. And we have quartile 1, which is at about, we'll call that 17. We need to subtract it, right? We have 34 minus 17 to get the IQR. That's 17. So the IQR is 17, okay? It says multiply the IQR by 1.5, okay? So we're going to go ahead and do 17 times 1.5. 17 times 1.5 is 16, 24, something like 23.5, excuse me, 23.50, okay? So we're going to go ahead and say that that is going to be the IQR times 1.5, and now we have to use that with these 2 numbers. So we need to find out, for step number 3, take our IQR, which we said was 34, and add it to 23.5, 23, excuse me, 23, let's see if I can fix that there, 23.5. Okay, well, 34 plus 23.5 is going to be 57.5, and then we check, is there anything above 57.5? Here is roughly 57.5. Is there anything above there? Yes. This data are outliers. Okay, because it's above that 57.5. Specifically, we know this is the maximum, right? So we can say that looks like it's about 62 is an outlier. Okay, now we need to check and see, is there anything that is just too low? Okay, so if I look down below, I see I'm going to use step number 4, subtract your first quartile to your IQR times 1.5. So we're going to do quartile 1, which is, what do we say, 17, and we're going to minus 23.5. When I do that, I'm going to get negative 6.5, and we're looking, is there any data lower than negative 6.5 again? No. Our lowest piece of data looks like it's roughly at maybe 12 or 13. So there are no more outliers that are too low. The only outlier that we have is 62.5, okay? Again, that was done by those 4 steps. They're there for you. You're going to be asked to do this on an Edge Elastic question or 2 or 3. So go ahead and take the time to get comfortable with that, and have this screen up if you think it'll help you while finding out if there's mathematical outliers in some of the data questions presented on that Edge Elastic. Thank you for following along, and we will meet here soon.